Hi, in this video I will explain the balance of system calculation. After completing the PV array and inverter configuration, we can start with the balance of system calculation. The calculation here has two parts. The first part is on the DC side, the second part is on the AC side. We will start by the DC side. As you can see here, we have the string calculation, we have the subarray level calculation, and we have the array level calculation. The balance of system calculation can do the voltage drop calculation, fuse rating, cable sizing, subarray, cable sizing and fuse rating, and on the array level it can calculate the DC disconnector rating and the cable size. It also calculates the array open circuit voltage and short circuit current. To start with the BAS calculation, we have to add the MPPTs. We click on add MPPT button. This inverter has only two MPPTs. We click on MPPT1 and start with the calculation. To do the calculation for MPPT2, you click on MPPT2. We start with MPPT1. You have to specify the number of strings per input. As shown here, you can put 2. Number of modules per string, it has to be between 10 and 19. I will use 18 here. The string cable length, it's the distance between the furthest PV module and the combiner box. I will use 30 meters here. The string voltage drop, I will put 1. For the subarray, if you have a subarray, you have to specify the subarray cable length and voltage drop. If you don't have a subarray, just leave this number as 1 here. For the array, we will specify the array cable length, which is the cable length between the combiner box and the PV inverter. I will use 35 here. And the required voltage drop, I'll use 1% here, and click on calculate BOS. As you can see, the actual voltage drop is 0.49. The fuse rating has to be between 17.4 and 20, and the minimum cable size is 4 mil. For the array, so the array DC disconnector rating has to be minimum 29.6 amp, and the minimum array cable size is 6. The open circuit voltage is shown here. The short circuit current is shown here. If you want to have a better understanding on the string, subarray and array, you can click on show single line diagram and you can see the configuration here. In this example, we are using this configuration. So you can see the PV array, you can see the string, and you can see the combiner box and the fusing and also the DC disconnectors. This is the first part of the calculation. The second part is the AC cable sizing and voltage drop calculation. You can choose either cable sizing calculation or voltage drop calculation. You have to specify the system voltage and you have to specify the conductor temperature depending on the cable insulation. To do the cable sizing, we have to specify the the maximum current. You have to specify the cable length, which is the cable length between the PV inverter and the main switchboard. The required voltage rise 1%, and you click on calculate. You will obtain the required AC cable size and the actual voltage drop.